Alright, so I apologize that my video is getting up just today. So on this first section of homework, we're going to be looking at to the nearest cubic centimeter, what is the volume of this cylinder. So I'm going to be doing a lot of formula substitute solve in this homework. So for the first one, we're looking for the volume of a cylinder. So directly from our formula chart, we're going to have volume equals capital B H. So what we have to remember is that capital B equals the area of the base. So in our case right here, we're going to have our base is a circle. So when we substitute in, we're going to have actually pi r squared, because the area of a circle area formula equals pi r squared. So we're going to multiply that by our height. So when we substitute, we're going to take, I'm going to use 3.14 for pi. 3.14 times our radius, which is 4.4 squared. And then we're going to multiply that by our height of 0.8. So when we solve this, you can put it into your calculator just like this. 3.14 times 4.4 squared times 8, or 0.8. So that will give us a volume, and we're to the nearest cubic centimeter. So that means we're going to round to, there are going to be no decimals in our answer. So our answer here is 48.6. So they're saying no decimals, we just need one answer. So we're going to look at this right here, and we will have volume equals 49 centimeters cubed. And if you would have used pi rather than 3.14, you would have still gotten the same. You would have rounded to the same number. So remember, going on. So again, to the nearest tenth of a cubic centimeter, what is the volume of a sphere if our radius is 17 centimeters? I'm going to go ahead and write that in right there. So our formula for this is going to be volume equals 4/3 pi r cubed. So when we substitute here, we're going to have volume equals 4/3 times 3.14 times 17 cubed. So when you put it in your calculator, 4/3 4/3 times 3.14 times 17 to the third power, 17 cubed. And our answer will be, for our solution, volume equals 20,569.093, repeating, but we have to go to the nearest tenth, so we only have room for one decimal place, so we have to look at this number behind it. So our final answer is going to be 20,569.1. Right. Go here. Which expression represents the volume in cubic centimeters of the cylinder represented in the diagram below? So we're looking for the volume. So our formula is going to be volume equals capital B times H. So they have given us a diameter of 12 centimeters. So our radius is going to be 6 centimeters. So again, when we have capital B, we're going to remember that this is going to be for our circle, since we have a circular base, we're going to have the area is pi r squared here times h. So when we substitute in, we're going to have 3.14. Actually, in our answer choices, I just realized, our answer choices are in the terms of pi. So we're going to leave pi in our answer. So we're going to have our radius, which is 6 squared, times our height of 27. So from there, you should be able to solve. So you'll want to square this. So this will be 6 times 6 is 36 times 27 times pi. So from there, you're going to want to leave your answer in terms of pi. So if you see here, they've left pi in all their answers to keep it cleaner. So show your work FSS for all 3 figures to prove your answer. Which diagram represents the figure with the greatest volume? All right, so I know you don't have as much room. We'll start with the sphere. So formula is going to be V equals 4/3 pi r cubed. Substitution will look like 4/3 times 3.14 times, so they gave us this here is going to be our diameter. So our radius is going to be half of that, 2 inches. So times 2 to the 3rd power. So from there, you should be able to put that in your calculator and get an answer. Over here, we have our formula. V equals, for a cylinder, capital BH. For our substitution, V equals, once again, our base is a circle. So B being the area of the base, we're going to have pi r squared in there for that. So when we substitute in, we're going to have 3.14 times our radius. So again, they gave us the diameter. So our radius is going to actually only be half of this. So we're going to have 2 squared times our height, which is 4. So go ahead and you can find your solution there. And the last one, we have our cone. So formula equals 1/3 capital BH. V equals, this is our formula. For our substitution, V equals 1/3. Again, our base is a circle. So in place of this B right here, because big B, capital B, is the area of our base, which is pi r squared. So we're going to multiply that 3.14 times our radius. Once again, they have given us this, which is our diameter. So once again, our radius is, this is our radius. So our radius is going to be 2 squared, and then our height last is 4. And so for our solution, we're going to have V equals, when you multiply all those together. So that is our volume review. And moving on, in the surface area, so we're moving to a different section of our formula chart. We have some variables. So we have capital P, so they're both capital letters, uppercase. So capital P is going to be the perimeter of the base, and then capital B is going to be the area of the base. All right, so now we have find the measure of angle 1 when measure of angle 5 is 65 degrees. So I'm going to locate angle 5. It's right here. And they're saying that this is going to be 65 degrees. So I think the best option is to go ahead and fill in when we have a straight line. So straight line equals 180 degrees. So from there, we have 65. So if we want to take and finish to find angle 6, we have 180 minus 65. So this is going to be 115. And then we know that this angle right here and this angle right here, since they are vertical angles, we're going to have 65 and 115. So the hint that I'll give you, this right here, if we were to move, if we were to slide this up right here, that is what we know about when a transversal line cuts two parallels. So if you look, these angles should be the same. All right. Moving on. Okay, it says draw a line segment AB on a coordinate plane. Find the length of segment AB to the nearest tenth. So we have a line right here, and we haven't learned how to find the distance between 2 points, but what we have learned is that when we have a graph, we can create a right triangle. So this is going to be our right triangle. So we're going to have A, B, and C because we have our angle, our right angle pointing. So we can see that this is 1, 2, 3 long, and we can see this is 1, 2, 3, 4, 5, 6, 7 long. So we're going to have formula a squared plus b squared equals c squared. Substitution is going to look like 3 squared plus 7 squared equals c squared. And from there, you should be able to solve that out. Well, this would reduce a little. 3 squared is 9 plus 49 equals c squared. So you should be able to find that from here. All right. So if we wanted to find we're looking for the measure of angle A. So we're looking for this one and this one. So they have some x's. I'm going to go ahead, since this right here is a straight line, we know that this total has to be 180. So just to find what the measure of angle C, we can take 180 and subtract 83 from that. So 180 minus 83 is going to be 97. So we already know this is 97. So that's going to help us because when we have, so for a triangle, we have the measure of A plus the measure of angle B plus the measure of angle C equals 180 degrees. So from there, we can just substitute 9x plus 4 plus 4x plus 1 plus 97 equals 180. So we're going to have to, first step, we're going to have to combine our like terms. So I'm going to go ahead and circle my constants. And box my variables. So we have a 9x and a 4x, which is going to give us a 13x. And then we have 4 plus 1 is 5, plus 97, which is going to give us 102 equals 180. So from there, we're going to subtract 102 from both sides. That will become 0. We'll be left with 13x equals 78. And so then in order to find x, we'll have to divide both sides by 13. This will become 1. 78 divided by 13 is 6. So we then have to take our x right here. We're going to take our x, and we have to substitute that in for our x here and our x here in order to find what our measures are. So we're going to have 9 times 6 plus 4, and we're going to have 4 times 6 plus 1. So from there, you should be able to substitute in, so then we'll have the measure of angle A equals, and the measure of angle B equals. Once you simplify those. All right, and our last section. So I'm going to shade in, I'm going to use this one as my base. So what we're looking for is our capital P, our capital B, and our height. So we have two bases in this rectangular prism, and it is connected by our height right here. So I'm going to use, so this right here, this pink right here is going to go around the perimeter of our base. So from there, I'm going to redraw my base, and I'm going to input my answer, my dimensions. So we're going to have a 2 and a 4, 2 and a 4. So for the perimeter of our base, perimeter of base, this right here is the area of base and our height. So when we add perimeter plus, we're going to have 2 plus 4 is 8, and 4 plus 2 is 6 plus 6 equals 12. Area of our base is going to be 4 times 2, which is 8. And our height is going to be 4.5. So for the total surface area, the formula we're going to be using, surface area equals capital P times H plus 2 times the area of our base. So our substitution is going to look like the perimeter of our base, which is 12, times our height, which is 4.5, plus 2 times our big B, our capital B, which is going to be 8. So from there, you should be able to solve and simplify to be able to find the total surface area. All right, here we go. We have a triangle, and we're given 3 different angles. We're given 2x plus 1, 3x minus 3, and 9x. So when we're looking for the measure of the smallest angle. So, and when you have 3 angles, we're going to be able to, when we're solving for angles, we're going to be setting equal to 180 degrees. So 180 degrees equals 2x plus 1 plus 3x minus 3 plus 9x. So again, I'm going to try and I'm going to box variables, circle constants, box variables, circle constants, box variables, and circle constants. So from there, we're going to just solve for x. So we're going to combine all of our x's, which would be 9 plus 5, which is 14x. And then we're going to have 1 minus 3. And that's going to give us a negative 2 because we can't change our signs. So 180, we're going to add 2 to both sides. We have 182 equals 182 hold on, I did something wrong. Two x 5 is 9, 1 minus 2 plus 2. 182 divided by 14. Sorry guys, so this is correct, 14x. I was dividing by 180. So this become 1, so our x is going to be 13. So now we have our three angles. We have 2x plus 1, we have 3x minus 3, and 9x. So we're going to have to take this x right here, we're going to have to substitute it in here, here, and here to see which one is our 2 times 13 plus 1, 3 times 13 minus 3, and 9 times 13. So from there you'll be able to determine which is the smallest angle. All right, here we go on use the known lengths of the squares that form the right triangle to find length x of the third square. So if we have a square, we're going to have 4.8 on each side. We're going to have 2.3 on each side. We're going to have an x. So I'm just going to redraw my right triangle right here. So we're going to have an x, we have a right triangle, we have a 2.3, and we have a 4.8. So from here, the formula that we're going to use in order to solve for the side length of a right triangle is going to be a squared plus b squared equals c squared. So our substitution is going to look like 2.3 squared plus x squared equals 4.8 squared. So the way that I know that this is right here equals c is because I drew it here too. So my right angle always points to my hypotenuse, or c, which is the longest length. So we're going to want to simplify that. 2.3 squared, which is 5.29 plus x squared equals 4.8 squared, 23.04. So again, we're going to want to subtract 5.29 from both sides. So we're going to be left with x squared equals 17.75. And then from there, we're just looking for an x. And this is an x squared, so we have to unsquare this in order to find x. All right, last problem. We're looking for the volume of a sphere with a diameter of 50 meters. So the formula we're going to be looking at for volume of a sphere is 4/3 pi r cubed. So when we substitute here, we're going to have volume equals 4/3 times 3.14 times, so we do not have a we have our diameter, so our radius is going to be half, because if we have a circle, the whole thing across, this whole thing across is this is our diameter, but our radius is only half. So our radius is that little piece here. So this is going to be 25 meters. So I'm going to go ahead and 25 cubed. So from there you should be able to calculate that out to get your answer in meters cubed, and I just underlined here, it asks us to round to the nearest tenth, meaning there is only going to be one number after your decimal. The 10th place is one number after. So from there, here is the homework, and hopefully that helps.